All right, so I'm going to just try and do the ones that you need to know for my math lab. Okay. Okay, so number 2, it says this: the length and width of a rectangle represent. Okay, so in translating from 1 through 6, it says represent each given condition using the single variable x. So you're told that the length and width of a rectangle whose length is twice its width. All right, so number 2, they're saying if this is x, then how would you represent the length? Not x squared, 2x, right? Twice its length. All right, so that's all they want in number 2. They just want you to represent the conditions. Now you're going to use that information in a little while to set up an equation. So let's look at, I'm trying to find one that's similar to the worksheet, to my math lab. All right, so let's look at, let's look at number 1. So in my math lab, they're going to have one like 1 and 2. It's going to say represent a given condition using the single variable x, just like it did in number 2. And so you have this rectangle, and you're told that the width is x. This will be the same thing on my math lab. You can be given this rectangle. Then it says this, the one in the worksheet, not the one on my math lab, but it's similar. The length and the width of a rectangle whose length is 4 centimeters more than its width. So if this is x, how would you represent the length?
X plus 4.
X plus 4. So in my math lab, this is what they have. They have the width of the rectangle. This is my math lab. So the length of the rectangle is blank, and the length of the rectangle is blank. And so what's the width of the rectangle represented as here?
X.
And what are you going to put here?
X plus 4.
X plus 4. So that's what you put on my math lab. Okay? This will be my math lab. Okay, now let's look at number 4. So same thing. You're going to let x represent the unknown here. So number 4, you're told that you have what kind of integers?
Consecutive.
2 consecutive even. Okay. So you're going to let x equal the first. All right, so if x is the first even integer, then how would you represent the second even integer?
X plus 1.
Okay, let's think about this. If my first even integer is 6, what's the next one? 8. So how do we get 8? 6 plus 2. Okay? So it's not 6, it's x. So how do I represent the next one?
X plus 2.
X plus 2. So the next one will be x plus 2. Now my math lab is going to look like this. All right, so my math lab is going to say the first even integer is blank. What are you going to say? X. Then it's going to say the next consecutive even integer is blank, and what are you going to say? X plus 2. Okay? So let's look at number 3. This time you deal with what kind of integers? Odd. Okay, so same idea. My math lab. The first odd integer is what? X. All right, now think about this. The next consecutive, the next consecutive odd integer is
X plus 2.
x plus 2. So if my first one's 5, the next one is what? 7. How'd I get 7? 5 plus 2. So regardless of whether it's consecutive even or consecutive odd, the expressions are the same. It's going to be x plus 2, the next one will be x plus 4, x plus 6, and so on. Okay? So when people think of odd, they want to say x plus 1 or x plus 3. You got to think about an odd number. An odd number would be something like 9, right?
Yes.
What's the next odd number? 11. I don't say 9 plus 1, I say 9 plus what? 2. So that's why it's x plus 2 in both of these. Regardless of whether it's consecutive even or consecutive odd, those are the same, x plus 2. So if x is even, the next even is x plus 2. If x is odd, the next odd is x plus 2. Okay? All right, let's look at number 7. Okay, now number 7, it says that the area of the square is 121 square units. And you want to find the length of its sides. You want to find the length of its sides. Okay? All right. Now remember, it doesn't look like a square that I drew, but it's a square. And what do you remember about the sides of a square? They're all the same. And the area is length times width, right? So if this axis is x, those are the same. So what number times itself is 121? 11. Okay? So x has to be what? 11 units. Now my math lab, this is what it's going to say. It's going to say the length of each of the square sides is blank, and then it's going to have the number 1 here, and I'll explain what that is, and then another blank. So blank 1 blank. Okay? Now let's think about what goes in those blanks so before we talk about 1. So the length of each side is what? 11 what? No, not 11, 11 what? Okay, so suppose we're talking about this right here, this room. So let's say this is a square. It's not, it's a rectangle. Let's say it's a square. And let's say this is 13 feet. Then this has to be what? 13 feet. So the length of each side is 13 feet. So your units in this case is feet. 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 The units here is represented as units. So you can say 11 what? Units. 11 units. Okay? So on my math lab, this one right here, when you look at it, it's going to have this. It's going to have some choices. You'll have one here, and it'll have something like units cubed, units square, and then units with little ovals here. So which oval are you going to choose? Units. And choose this one here. And then the number, the part that goes here, the part that goes here will be what? I'm sorry, the part that goes here will be what? 11, and this will be units. So you're going to put 11 here, and you're going to put, for 1, you're going to put this. Okay. Okay, then let's look at number 9. Number 9, you have this quadrilateral. And this side's x plus 5. This side's x plus 3. This side's 3x minus 8. And this side's x squared minus 3x. Okay? All right. So you have this quadrilateral. Those are the 4 sides. And you're told in the problem, number 9, that the perimeter of this quadrilateral is what? 120 centimeters. What does perimeter mean? What about the outside? What do you do to the sides? You add them up. So the perimeter means the distance around a figure. That's what that means. The distance around it. So your equation, you have a separate equation. Your equation then would be what? Which one do you want to start with? X plus 5. Okay, so it'll be x plus 5. So that side plus the x squared minus 3x. So that side plus 3x minus 8 plus x plus 3. And all that has to equal what? 121. So number 9 is different from the others because the others you could have easily done without too much work. Now you have to do some work in number 9. Number 9, what kind of equation is that? What kind of equation number 9? Quadratic. Number 9 is quadratic. You have that x squared. So you have to put it in standard form. But first of all, let's combine like terms on the left. When I combine like terms on the left, what do I get? There's only one x squared, right? Okay, let's combine the x's. X minus 3x is what? Negative 2x plus 3x is what? X plus x is 2x. So far I have x squared plus 2x. Now the constant. 5 and a negative 8 is negative 3. A negative 3 and a positive 3 is 0. And all that's equal to what? 121. So I have x squared plus 2x equals 121. 120? Oh, I'm sorry. I'm looking at number 7. 120, right? 120. All right, 120. Okay. Now what? That was that part. The rest of this is what you had on a worksheet. What do you do next? Before you do that, what do you do? What's that? You got to say, put it in standard form. So you have 0 on the other side. Subtract 120, so you can have x squared plus 2x minus 120 equals 0. Now do what? Factor. All right. So what do you want to try for 120? 2 and 12. 2 and 12 is 20.
10 and 12, I'm sorry.
10 and 12?
Yeah.
All right. So the last sign's negative, so that means that both signs are different. And 12 is going to be positive, right?
Yes. That's what it,
Good.
and it's going to be.
All right. Now what do?
You said those equal to 0.
So x minus 10 equals 0. X plus 12 equals 0. So using a zero factor property.
10.
So x is 10 here. X is
Negative 12.
negative 12 here. Okay. So that's where we're at. Okay. All right. Hold on. Now, on the worksheet, that would be your solutions. You would say 10 and negative 12 on that previous worksheet. But this is a word problem. And so you got to look at the context of this problem. In a 9, those are sides. And so if you look at a table, your table, when you talk about the length of the table, the width of the table, it's always what kind of number?
Positive.
Positive. So if I plug in negative 12 in for x, what's negative 12 plus 3? Negative 9. So you know that's not going to work. Your side length cannot be negative. So in terms of the context of this, can I use negative 12 for x? No, I cannot use negative 12 for x. Okay? Now, let's answer the question. Find the lengths of the sides, right? Okay, so I know I can't use negative 12, so I'm going to use what? 10. I've used 10. All right, so then you're going to go to each side and you're going to substitute 10. What's 10 plus 5? 15. Okay, what's 10 plus 3? 13. All right, 3 times 10 is 30. 30 minus 8 is 22. Is that correct? What's 10 squared? Remember, this is 10 squared minus 3 times 10, right? So 100 minus 30 is 70. So those are your side lengths. Okay, make sure you understand why we can use 12, because if I plug in 12 into any of these, I get a negative side length. So I have to use 10 instead. Now remember on the previous worksheet where it was just solving a quadratic equation, those would be your solutions. But negative 12 we can't use because in the context of this, you can't have negative length. Okay? All right, so that's number 9. Now the way it's going to look on my math lab, it will say this. My math lab, it'll say, all right, it'll say side 1 equal, and then it's going to write the expression. Oh, good Lord, why did it do that? Shoot. All right, then it'll write the expression x plus 5. And it'll say side 2 equal, and it'll do the next expression, x plus 3. And then so on. And then it'll have, again, 1, 2, 3, 4. Okay? And so you would say, remember, x in this case is what? 10, right? X is 10. So then you would say side 1 would be 10 plus 5, which is what? So it would be 15, and then this would be, I think there are units here, centimeters? And then this would be 13 centimeters and so on. Okay? So the way it's going to look in my math lab, it'll look like this. So you're going to put 15 and then centimeters, 13 centimeters, and so on. Number 1, it'll do this. It'll have centimeters cubed, centimeters squared, centimeters. Number 2, centimeters cubed, centimeters squared, centimeters. 3, and so on. You have ovals, and all you do is just choose the correct ovals. Which oval will you choose each time? Centimeters. That's the one you'll choose each time. Okay? All right. Okay, let's look at number okay, let's look at 14. I'm sorry, let's go ahead and do 13. 13. Let's do 13. So in 13, you have that an object is thrown upward from the top of an 80-foot building with the initial velocity of 64 feet per second. The height, h, of the object after t seconds is given by this function, negative 16t squared plus 64t plus 80. Okay, now this function is what kind of function? Quadratic. All you've done so far is dealt with linear and quadratic. So you know this is linear because of the t squared. This is quadratic. And the question is, when will the object hit the ground? Well, remember, what does h represent?
Height,
The height where?
from the fall.
It says the height h of the object after t seconds, right? Okay, so and so the question is, when will the when will the object hit the ground? So the ground. Let me draw this for you. This is the building, correct? Where's this person located? On the top of the building. Right here. So you're going to throw the object, and it's going to hit the ground, correct? Okay? And this building is how many feet tall? 80 feet. And so the height, and it says height is the height of the object after t seconds. All right, so when it hits the ground, what's the height? 0. You agree? Height 0. Right here, what's the height right here? 80 feet. When it hits the ground, what's the height? 0. So when you set up this equation, what does h become? 0. So negative 16t squared plus 64t plus 80 must equal 0. Okay. Now, let me remind you, or let me go back to a previous problem. Before we finish this, let me go back to a previous problem from a worksheet, or similar to one on a worksheet. And then we'll come back to this one. So I want to show you something. Suppose you want to solve this equation. And I'm making this up for the moment. Let's suppose it was all right, suppose we had (4x squared) plus 10x minus 6 equals 0. Okay? All right, and on test number 2, and this is on test number 2 right here. On test number 2, how would you solve this equation? Okay, so one way we do that is, first of all, it's in standard form, right? Okay, so you found the GCF, and what's the GCF? 2. Okay, so you factor out the 2, and so you said this was 2 times 2x squared plus 5x minus 3 equals 0, correct? All right. Then you did what? Factor this, so it's 2 times, and the one in your test is factorable. Towards the last test is where it's not going to be factorable, so you have to use the quadratic formula. So we'll talk about that at that point. 2xx, where you want to put the 3? I think the 3 goes here. The 1 goes here. Middle sign's positive, which means 3 has to be positive. This has to be negative. Okay? Then, on that last worksheet I gave you, some of you asked me about, well, what do I do with the 2? Remember that? Well, remember we said each factor equals 0, correct? And how many factors do you see here? 3. So you would say, in your mind, you would say, all right, I'm going to say each one equals 0. I'm going to say 2 equals 0, 2x minus 1 equals 0, x plus 3 equals 0, correct? But if you look at that first one, that doesn't make any sense. 2 does not equal what? 0. So I really can't use that one. I mean, I can't use that one at all. Because first of all, it doesn't have any variable in it. So that other equation, though, I can solve for x. You'd say 2x equal what? 1, and x is 1/2. So that's one of your solutions. Over here, you say x equal what? -3, and that would be your other solution. Now remember, a while ago we solved the word problem in which the variable the solution turned out to be negative and we couldn't use it. So you got to look at the context of a problem if it's a word problem. But what you remember is this. If you look at the original problem again, that's an equation. And we learned last semester something called the property of equality. And one of the properties of equality was that what I do to one side, I do to the other. So the addition property of equality said if I add something to one side, I add it to the other. The multiplication property of equality says if I divide one side of the equation by a number, I do it to the other side, right? So if I want to, couldn't I have just divided both sides by 2? I can divide by a number. I can multiply by a number. And so when I divide by 2, what's 4x squared divided by 2? 2x squared. What's 10x divided by 2? 5x. And what's -6 divided by 2? And what's 0 divided by 2? And that right here is just this. And you might say, well, when we did factoring, you said to take out the 2. Yeah, but there's a difference between factoring and solving an equation. So in factoring, so you got to be a little bit careful when you look at factoring versus solving. So on your test 2, if it said factor 4x squared plus 10x minus 6, could I get rid of that 2? No, because that's not an equation. This is not an equation. So if it said factor, y'all agree that's not an equation, right? If it said factor, then you have to do the GCF. The GCF has to be part of your answer. And so your answer would be 2 times, 2x minus 1, x plus 3? That would be your answer. If it said factor. If it said solve this equation, then I could divide both sides by 2. Because I just want to find out what x is. I'm going to solve this by factoring. And I'm still using factoring. I'm just dividing by 2 first. And I'm going to factor. So you get 2x minus 1, x plus 3, and then you set each one equal to 0. Okay? So x is 1/2. And over here, x equal -3. There's your solution. So you got to remember the difference between solving and factoring. So here, I could have divided both sides by 2 because that's an equation. What I do to one side, I do the other. Here, that's not an equation. That's an expression. So all you can do is factor out the 2. Don't get rid of it because that 2 is part of your answer for this, for factoring. All right, that brings me down back to number 13. Okay, what makes this difficult to factor? The negative coefficient of t squared. But what can I do to both sides if you look at it carefully? I can divide both sides by what? -4, what else? I think -16 goes into all of those. -16 goes into all of them. So I can divide both sides by -16. And so what's -16 t squared divided by -16? Positive t squared. What's a -64 divided by positive 64 divided by -16?
-3.
No, -3. -4. What's a positive 8 divided by -16? Yeah, 14. So that's minus 5, right? Equals 0. Okay. Now, is it easy to factor this? Yes. So I can factor this as t minus 5 times t plus 1, correct? Now I set each one equal to 0. And so t here is 5. T here is what? Negative 1. Okay. Remember, this is a word problem, so let's think about the context of this. Can I use both of those, or can I use none of them, or can I use just one of them? All I can use is t is what? 5. So it's going to hit the ground after how many seconds it's been thrown? 5 seconds. So the object hits the ground in 5 seconds. Okay? All right. So that worksheet last time that I gave you where we had this and you were asking about what about the 2, you could have divided both sides by 2, and that's one of the reasons why I brought this up as well. All right. But most of you did not because you didn't know about that. You forgot about the property. But you could have just factored out a 2 and just not used it. Now, be careful. There is a difference between this now. Watch. Suppose I had this. This versus this. So here, how many solutions were there? No. Here. No. There are only 2. X is 1/2 and X is negative 3, right? If I had this, how many solutions are there? There are 3, because now I can say 2x equal what? And so what's x? 0. Here I can say 2x minus 1 equals 0, and what's x? 1/2, and here x plus 3 equals 0, which x is what? 3. Negative 3, I'm sorry. Negative 3.
So if it has
A variable like that?
that's the word I was looking for, I'm sorry, then you can add that as another one.
Yeah, because you're setting each of those factors equal to 0.
Right. Okay.
So I can, technically there are 4 factors here. There's a 2, an x, a 2x minus 1, and an x plus 3, but we tend to put the 2x together. Here, when I set each of those equal 0, when I set 2 equal to 0, that didn't make any sense because 2 does not equal 0. There's no way 2 can be 0. Here, there is a way 2x can equal 0, and that's when x is what? 0. And then, let's see what else is on my math lab. Okay, so, all right, and then let's look at number, if the sum of the number and its square is 30, how many numbers? Okay, let's look at number 21. 21. Okay, 21. Okay, the sum of a number and its square is 132. And you want to find the number, okay? The sum of a number and its square is 132. So we'll find the number. So we're going to let x equal the number. Let x equal the number. All right, and then it says this. The sum, what do we mean by sum? Add. So I'm adding 2 things. The sum of the number, how is the number represented? X. And its square. So what am I doing to that number? Squaring it, so it'll be x squared. And what do you know about that sum? 132. So that's your equation. So the sum of a number and its square is 132. What kind of equation is this? Quadratic. So let's put it in standard form in descending order. So how would I write this? minus 132 equal 0. Remember, standard form meaning you want 0 on the other side, right? Now let's factor this. So when I factor this, let's see, XX. Okay, you want two numbers whose sum is whose product is 132, and you want middle signs and as a positive 1. What do you want to try? 12 and 11. 12 times 11 is 132. Okay. All right. So last sign's negative, so these are different. So the 12 has to be what though? And this is okay. Then I use the zero factor property. X plus 12 equals 0. X minus 11 equals 0. So X is negative 12. X is 11, right? Okay. So that's where we're at. All right. And then it's going to say, all right, remember you want to find the number. So what did we let X be? The number, right? And I solved for X. So what's my number? 11. What about negative 12? Oh, okay. I'm glad you brought that up. In the context of this problem, what is X? The number, right? Does that have anything to do with distance or buildings or anything like that? No. Has nothing to do with that. In the context of the problem, can I square negative 12 and add negative 12 to that and get 132? Yes. It has nothing to do with distance, so you got to look at the context of the problem. The previous problem, you had the height. And remember, height must be what? Positive. Time must be what? Positive. Here, there's no building. It's just you're squaring a number and adding that square to that number, and you get a 132. So both of those are your numbers. Both of those are your numbers. All right, so you got to look at the context of the problem. So what my thought is going to say this. It's going to say the numbers knows the S's in parentheses because they want you to determine whether it's only one of them. Usually students are going to say it's just 11, but we know it's what? 11 negative 12. So the numbers is are, and then blank. And then it says this, use a comma to separate answers as needed. To separate answers as needed. So in the blank, you're going to say negative 12, comma what? 11. You're not going to put 11 because you're going to get 0 points for it. It's going to be negative 12, comma 11. So this situation where the negative solution is a solution. See here, I couldn't use negative 1 because time here is negative. You're saying negative 1 second? Time must always be what? Positive. Okay? And here, I couldn't use negative 12 because when I plugged in negative 12, one or more of my sides was what kind of distance? Negative. And distance can't be negative. So you got to look at the context of the problem. All right? Okay, and then let's see what else there is. Okay, so let's look at number okay, look at number Number 14. Number 14. All right, 14. Okay, it says a hang glider accidentally drops her compass from the top of a 400-foot cliff. The height of the compass after t seconds is given by this quadratic equation. Okay, and it says when will the compass hit the ground? All right. So when will it hit the ground? When h is what? 0. So negative 16t squared plus 400 equals 0, right? All right. Divide both sides by not just 16, because remember you want t squared to be positive. So negative 16, right? Okay, and so negative 16t squared divided by negative 16 is t squared. What's 400 divided by negative 16? Negative 25? And 0 divided by negative 16 is 0. And I could factor this because the difference of two squares. T minus 5, t plus 5. So what do each of those factors? Set them equal to 0, 0 factor property, right? So what's t over here? What's t over here? Can I use both? One? Just one of them. You're dealing with time. So which one can I use? 5. So it will hit the ground. In 5 seconds. Okay? All right, there's one more on my math lab that I'm trying to find an example like it. Let's see. Okay, here we go. Go to number 35. Number 35. All right, so all these problems we did, you're going to use in my math lab. So when you do that in my math lab, there's the quadratic equation we solved last week, and then there's these word problems. You use those word problems when you do that section. Okay, an object is dropped from 39 feet below the tip of the pinnacle atop one of the 1,483 foot tall. How do you pronounce that? Petronas Twin Tower in wherever, Malaysia. Kuala Lumpur, whatever. The height of the object after t seconds is given by this equation. H equal negative 16t squared plus 1,144. Now it says this. Find how many seconds pass before the object reaches the ground. Okay, so find how many seconds pass before the object reaches the ground. All right, well, when will the object reach the ground? When h is 0. So minus 16t squared plus 1,144 equals 0. All right, again, we don't like dealing with a negative coefficient for the square term, so in this case, I can actually divide both sides by negative 16. So negative 16t squared divided by negative 16 is? Huh? Oh, so it's not? Okay, let me make sure. Hold on. An object, okay, how many seconds? All right, so the object is dropped from 39 feet below the tip. Okay. Um,
Which is gonna be 1,444.
right.
Feet from the
Yeah.
CA3.
How many seconds pass before the object reaches the ground? I'm not sure. Oh, okay. So we're good because the one in your worksheet is a decimal. So this is a decimal, right?
Okay, okay.
Okay. So you're gonna say t squared, and what is this?
90.25.
So minus 90.25 equals 0, correct? All right. Now here's the thing. This is the difference of two squares, correct? Okay, so I want you to think about this like this. You know, this is t, this is t, this is plus and minus, correct? What two numbers multiplied by itself is 90.25? How do you determine that? No, don't divide by 2. Take the square root. So you calculate, take the square root of 90.25. 9.5? You see what I did? So remember, 9.5 times 9.5 is what? 90.25. So you use the square root. Use the square root. Now, when we get into the chapter dealing with radicals, you're going to see where that comes into play. But they want you to do this by factoring. So you said each one equal to 0. So t equals negative 9.5 here, and t equals what here? Which one do I use? 9.5. Okay. So when you do, and this is going to be number 22 in my math lab. When you do number 22, it's going to be a decimal. But that's what you do. So everyone we've done so far has been a nice whole number. Now you have a decimal. But it's difference of two squares. You just got to remember, how do I figure out what two numbers whose product is, what number times itself, its product is 90.25. You have to take the square root of 90.25. So when you take the square root of 9.25, you get 9.5. So when you do number 22, there's going to be number 22 in my math lab. It's look like this, so make sure you do the same thing. You have to use your calculator and then use the square root button. Okay? All right, any questions at this point? Okay, so that's the end of what we need to do with that section. So use these when you do that section from my math lab.
I have a question about number 21. Because I really plug it, like to plug it back in, shouldn't a number, because negative 12, if you plug it back into the original problem, does not equal to 0 or the 132. So
Okay, what's negative 12 squared?
144.
Okay, what's 144 plus a negative 12?
Oh, that's what I was like.
No, yeah. So usually what happens sometimes is they'll say negative 12 squared and they'll say negative 144 in the calculator, but you got to put negative 12 in parentheses and then squared to get that positive 144. All right. Okay, so that's the end of that. Okay. All right, now let's look at this. So this is section 7.1. It's an easy section. Easy section. I didn't mean 7.1. I meant 14.1. 14.1. Okay, so let's start looking at 14.1. It's not a difficult section. It's very easy. So listen carefully, though.
I'm saying it's not a difficult chapter.
It's not because in order to do this, you have to know how to factor. If you're not a factor, then you got this chapter. But you have to know how to factor. Okay, so we're this is going to be on page 1038. Okay, so one of the things you did previously was you evaluated expressions. So wherever you saw the variable x or the variable y, you plugged in some numbers and you evaluated it. same thing here. So in number 2, it looks like this, x plus 8 divided by x plus 1. And they want you to find the value of this expression if x is 2, y is negative 2, z is negative 5. So you're told that x is 2, y is negative 2, and z is negative 5. In this expression, though, what variable am I looking at? X. So wherever we see an x, what do I plug in, though? 2. So this is going to be 2 plus 8 divided by 2 plus 1. So what's my answer? 10/3?
Yes.
All right, 10/3. So it's number 2. Number 6. Here's the expression, x plus 5 divided by x squared plus 4x minus 8. And again, all they want you to do is find the value of that expression if you're given those values for the variables. So what's the only variable I need, though, in that in number 6? X. So this is going to be 2 plus 5 over 2 squared, that's an x, plus 4 times 2, right? Minus 8.
I was negative 2.
For x?
Sorry.
Okay.
Sorry, I wrote it wrong.
That's all right. So that's 7 divided by, all right, so in the denominator, order of operations, so you're going to square first. So that's 4, right? This is what? 8. So 4 plus 8 is 12, and 12 minus 8 is 4. So what do I get? 7/4. Number 4, you have z divided by z squared minus 5. What's z? Negative 5. All right, now, the denominator, that's z squared. So what am I doing to z? Squaring it. But I got to put that z in parentheses because it's negative. So I'm squaring it, and I'm subtracting 5. So my numerator is negative 5. My denominator, what's negative 5 squared? And what's 25 minus 5? 20. And then reduced, negative 1/4? 4, right? Negative 1/4? Okay. All right. Now, yeah, the direction is going to shift now. So here's a new set of directions. If I look at number 12, you have this expression. 5x plus 1 over x minus 9. Okay, now let's talk about a new word now. This expression right here is called a rational expression. A rational expression. It's very similar to the idea of a rational number. So for example, all these numbers right here, all those are rational numbers. 10/3 is a rational number. 7/4 is a rational number. Negative 1/4 is a rational number. 10 is a rational number. So a rational number is where you can write it as a fraction, a over b, where a and b are integers. A and b are integers. So if you look at 10/3, is 10 an integer? Is 3 an integer? Is 7 an integer? Is 4 an integer? Is negative 1 an integer? Yes. Is 4 an integer? And so on. So 10 I can write as 10 over 1. Okay? So a rational number, a rational expression is the same idea as a rational number, except the expression idea is a polynomial. So remember the expressions, 5x plus 1 is this expression. X minus 9 is this expression. It's written as a what? Fraction. So you have a rational expression. These are rational expressions. So all these are what? Rational expressions as well. All right, so rational expression, rational expression, rational expression. When you talked about a rational number, your denominator can never be what? No. What can't your denominator be? Remember, you can never divide by what? 0. So in a rational number, your denominator, you'll notice that the denominator is never 0. So now I want you to remember, you can have your denominator being negative. It's positive 7 divided by negative 2. Remember, a rational number is an integer divided by an integer. Is that an integer divided by an integer? Yes. It's just that your denominator cannot be what? 0, because that makes it undefined. So when you calculate, if you plug in 5 divided by 0, you're going to get an error. Okay, let's go back to number 12. What kind of expression is this? Rational expression. In a rational expression, my denominator can never be what? 0. Okay, so listen to the directions. Direction says, find any number for which this rational expression is undefined. Find any number for which this rational expression is undefined. A rational expression is undefined when what is 0? When the denominator is 0. And so all you do in this set of problems, to find out where this rational expression is 0, all you do is take the denominator and set it equal to 0. Do you do anything with the numerator?
No.
No, the numerator is not used at all. It's the denominator you're looking at. So you're asking yourself, well, if I want to find out where this is 0, then I'm going to have to set it equal to 0. And what kind of equation is this right here? You only dealt with 2 equations, quadratic or linear. What's this one? That's not quadratic. That's linear. So what's x? 9. All right. So again, the question is, find any numbers for x for which the rational expression is undefined. So what's the value for x that makes it undefined? 9. So 9 makes it undefined because look at the denominator. What's 9 minus 9?
0.
0. So you could look at that one and find the answer, right? But there are going to be situations in a little while where the denominator is not linear, but the denominator is quadratic. So you would have to set it equal to 0. So let's look at number 16. Number 16. Here's my rational expression. It's not difficult, guys. It's fairly easy. You have 19x cubed plus 2 divided by x squared minus x. 19x cubed plus 2 divided by x squared minus x. And so the question is, for what values of x is this rational expression undefined? Well, let's think about this. When is a rational expression undefined?
0.
When the denominator is 0. So if I want to find out where the denominator is 0, I got to set the denominator equal to 0. Okay? Now 0 is not the only solution though, so you got to solve it. How do you solve this quadratic equation? It's in standard form. How do you solve it? Factor. How are you going to do that though?
It's 0.
You already forgot.
No, it was 1 x minus 1. No, that's squared.
No, x times x equals
Huh?
You got the
The GCF, guys.
Oh,
1.
GCF is not 1. What's the GCF? GCF is x. GCF is x. So it's x times what? X minus 1 equals 0. So how many factors do you have here? 2. What are they? X, and what's the other? X minus 1. What do I do to both of those factors? Set them equal to 0. So x already by itself here. What's x over here? 1. So those are the 2 numbers that make the denominator 0. So what numbers make the denominator 0? 0 and 1. So let's check it. When x is 0, what's 0 squared? Minus 0. What's 0 minus 0? 0. Let's check 1. What's 1 squared? And what's 1 minus 1? 0. Right? But it went quite easy because you didn't know how to factor x squared minus x. Yeah. But y'all do know that this part's on test 2, right? This right here. Not this, but the idea of solving a quadratic equation. Come on, people. You got to find the GCF first. All right. Let's look at number 20. Number 20. All right. Not difficult. Remember, in order to be able to do this, you got to know how to factor. So you should know that by now. All right, 20. Let's look at 20. You have you have 11x squared plus 1 divided by, and some irrational expression is this, so the denominator is x squared minus 5x minus 14. All right, again, the directions ask you for what values of x is this rational expression undefined.
You said the bottom quadratic equation is equal to 0?
You said the denominator equal to 0. Because remember, a rational expression is defined when the denominator is what? 0. And then you ask yourself, what kind of equation is this? Quadratic. How do you solve a quadratic equation? Factor. It's got to be in standard form. Notice the difference between that one and number 16. Number 16 was a binomial quadratic equation. Here, that's a trinomial. Still look for the GCF. What's the GCF here? 1. So now you go to 2 binomials. All right. So what do you think is going to work? 7 and 2, right? And the 7 is going to be not positive, negative. All right. And now you're going to use the zero factor property. So x minus 7 equals 0. X plus 2 equals 0. So what's x? 7 and negative 2. So those are the numbers that make the denominator 0. Those are numbers that make the rational expression undefined. And again, you can check real quick. What's 7 squared? What's 5 times 7? 35. So 49 minus 35 is 14. 14 minus 14 is 0. Negative 2. What's negative 2 times itself? What's a negative 5 times a negative 2? Positive 10. 4 plus 10 is 14. Right. Okay. All right, so any questions on that? So that's all this part was. Okay? All right, now we're going to look at another idea, and then we'll do more with the next class period. All right, so I want you to look at this. Okay, so suppose we had this. And directions say simplify. And suppose I had 3x plus 6 divided by x plus 2. So what kind of expression is this? Rational. Now when they say simplify, when they ask you to simplify a rational expression, just like it did when they asked you to simplify 10 15ths. What does it mean to simplify 10 15ths? Reduce. And what do you do when you reduce? So you reduce or you divide by the common factors. What's the common factor here? 5. So you said 10 into 5 is 2, and 5 into 15 is, I didn't mean 10 to 5, I meant 5 into 10. 5 into 15 is 3. So you look for common factors, right? Same thing here. So if I'm going to look for common factors here, I'm going to factor. I got to factor. So you got to factor the numerator and factor the denominator. How do I factor the numerator? 3 times what? X plus 2. Can I factor the denominator? X plus 2. So when I did this one, I want you to look at this back, 10 and 10 15. So y'all agree that 10 is 5 times 2 and 15 is 5 times 3. And so what did I do here? Divide out the 5s. And you're left with what? 2/3. Same thing here. What do they have in common? X plus 2. So those divide out. Now when I say divide out, they're left in ones in their place, just like these. And so what's the only thing left? 3. So that's the idea we're gonna talk about. Now remember, in order to be able to do these, you gotta know how to factor. So when it says simplify, you're factoring, and you're gonna reduce the common factors, divide out the common factors. So it's very similar to simplifying a fraction like this. You see how the 5's divided out, the common factors? And you're left with 2/3. Now remember, when I divided them out, what's left in those places though? 1, because 5 into 5 is 1, 5 into 5 is 1. X plus 2 into x plus 2 is 1, x plus 2 into x plus 2 is 1. The same idea. So that's what we're going to go at next. So it's very simple, you just got to know how to factor. So most of what we do in this chapter has to do with factoring. Okay? All right. So let me see. I can give you a worksheet. And you remember to do a week from today, but the week from today is your test, so it's not going to be due until a Thursday. So let me see what I can give you. All right. So this is 14.1 Part A. So look at it. So here, for each of those, remember that's the first thing we did? So you evaluate given these numbers right here. Okay? Nowhere in here does I say show work, so you just put the answer right here. There's a back page, so always look at that. This is where you're going to tell me for what numbers for each rational expression is undefined. Okay? Now see how to do that, right? Okay. And that's about all I can give you right now. So to do a week from Thursday. Thursday. Okay, so take one. Okay, now here are the keys to the worksheets that are due today. Okay, these are the keys. Make sure you turn in the worksheets. I'm going to flip them. Now, everybody got the class notes from last period and the study guide?
Do you have any things? The study guide is laptop. Yes.